All right, here's our Unit 3 test review. These are the things that you're going to need to know for the test. Oh, I don't have a pointer. Now, know properties of concave and convex polygons. Know how and what the names of polygons are, such as triangle, quadrilateral, pentagon, hexagon, so on. Classify triangles. Know the names and properties of quadrilaterals. Know properties of parallel lines cut by transversal. Calculate exterior angle measure. Be able to calculate the number of sides a polygon has based on the interior angle measure. Calculate midsegment and base measures of trapezoids and triangles and be able to state theorems or properties that you used. Calculate slope. Calculate slope to determine lines are parallel or perpendicular. Calculate midpoint of a segment. Know reflection and rotation symmetry. Proof. Have your definitions, postulates, theorems, and properties available when you are completing a proof. And then there's angle pairs and whether they are supplementary or congruent. Now, to go over polygons, it says a polygon with all angles congruent is called an equiangular polygon. A polygon with all sides congruent is called an equilateral polygon. And a regular polygon is both equiangular and equilateral. Any regular polygon, not just this triangle. That could be a square, pentagon, hexagon, anything. Regular polygons have special properties. The center is the point inside the polygon that is equidistant from each vertex. An angle formed by line segments drawn from the center to two consecutive vertices is called the central angle. And here's an illustration. The measure of each central angle of a regular polygon is 360 degrees divided by the number of sides. And here's what that looks like, written out. Remember that your symmetry in regular polygons, if a figure has a rotation symmetry, then you can rotate it around its center less than one full turn, and the rotated figure looks exactly like the original figure. All regular polygons have both reflection symmetry and rotation symmetry, and the number of axes of symmetry in a regular polygon is equal to the number of sides. So if it's a pentagon, then it has 5 axes of symmetry. The smallest angle by which a regular polygon can be rotated to look exactly like the original polygon is going to be the measure of its central angle. Parallelograms and their properties. Remember, these are all the properties of a parallelogram, that the opposite sides are congruent. So EF is going to be parallel to HG, HG is parallel to FG. Opposite angles are congruent, consecutive angles are supplementary, and remember consecutive means that they're next to each other. And then the diagonals will bisect each other. Remember, rectangles have all the properties of a parallelogram, plus their diagonals are congruent. Rhombi have all the properties of a parallelogram, plus the diagonals are perpendicular, and the diagonals will bisect the vertices. And a square is a parallelogram with 4 congruent sides and 4 right angles. That means it is both a rectangle and a rhombus, which means that it's going to have all the properties of a parallelogram, a rectangle, and a rhombus. A trapezoid is a quadrilateral with exactly one pair of parallel sides. It is not a parallelogram, so it doesn't have any of its properties. And here's a Venn diagram showing the relationship of all these quadrilaterals. The blue box represents quadrilaterals. The red circle represents parallelograms. And notice inside parallelograms is a blue circle and a yellow circle that overlap. The rectangles are the blue circle, It's not rhombuses, it's rhombi. Rhombi is in the yellow circle, and where they overlap is going to be squares. And then trapezoids are in the green circle all by themselves because they don't share any of the properties of the other quadrilaterals. In this example, we're just going to go through this right quick. I'm going to use a highlighter for some of it. It says name 4 pairs of vertical angles. So if I'm going to name them, there's 1 and 3 are vertical. And then I can come down here. I'm going to change my ink color to this blue. 2 and 4 are vertical angles. Change my color again. Use this pink. I got 8. Oh, it doesn't show up very well. I'm going to go over it really good. 8 and 6 are vertical angles. And one more color change here. And then 7 and 5 are vertical angles. Now then, the next step that it has us do, part B, it says name all angles that form a linear pair with angle 7. So that's going to be angles that are right next to angle 7. See if I wasn't being able to get my pen to work. So part B, let me see what I changed my board there a little bit. So angle 7 linear pairs, angle 7 and angle 6 is a linear pair, and angle 7 and angle 8 are a linear pair. And remember, linear pairs add up to 180. It said name all the angles that are congruent with angle 1. That's part C. Angle 1, okay, vertical angles are always congruent, so angle 1 is going to be congruent to angle 3. And angle 3 and angle 6 are corresponding angles. So angle 1, remember by the transitive property, is going to be congruent to angle 6. And angle 1, and plus their alternate exterior angles. Angle 1 is also going to be congruent to angle 8. I believe that's it. So angle 1 and angle 3, those are vertical angles. Angle 1 and angle 6 are alternate exterior angles. Angle 1 and angle 8 are corresponding angles. Part D says name all the angles that are congruent to angle 4. Well, you're going to go through the same process. Of course, angle 4 is going to be congruent to angle 2. Those are vertical angles. And then we got angle 4 is congruent to angle 5. Those are corresponding angles. And then angle 4 is going to be congruent to angle 7 because they are alternate exterior angles. Part E says name angles that are supplementary to angle 3. So angle 3 plus angle 2 is going to equal 180. Angle 3, and that's because they're a linear pair. Angle 3 plus angle 5 is going to equal 180, and that's because they're same side interior angles. And then angle 3 plus angle 4 equals 180. They are also a linear pair. I'm just looking through it right here, right quick. Angle 3 and angle 7 aren't a pair? But let me explain. Angle 3 is supplementary to angle 5, and angle 5 is congruent to angle 7 because they're vertical angles. Okay, so that's why they're going to add up to 180. They're not a special pair. And then you would go through the same process with doing angles, those that are supplementary to angle 2. Okay, this one says, given the following information, determine which lines, if any, are parallel and state the postulate theorem that justifies our answer. And I went over this one in a recording, but if I looked at the measure of angle BCG, which is this one, and then FGC, which is this one right here, that proves that KD is parallel to EG, and that's because of the same side interior angles. Oh, and that's the converse. I'm not going to have enough room to write that out. I'll just keep it going down there. Converse of the same side interior angles theorem. 2 says, and I probably need to erase what I did with the 1 so it doesn't get confusing. Oops. Well, I'm just going to push a whole bunch of buttons. Okay, angle CBF right here is congruent to GFH. GFH right here. And that's going to make KD parallel to EG, and that looks like it's going to be because of the converse of corresponding angles. That's a postulate. And then let's look at another one. Let me erase that without pushing a whole bunch of buttons. Angle EFB. EFB is congruent to FBC right there. And there again, we've got the same lines. KD is parallel to EG. And that is going to be because of the converse of alternate interior angles. And that's a theorem. I should have put theorem up here too. That's a theorem as well. Okay, and then last but not least, let's look at number 4, which says ACD right here is congruent with KBF. Oh, we got a different set of lines here. We're going to say that line BF is parallel to line AG, and that looks like the converse of alternate exterior angles theorem. All right, proving lines parallel. Now when you're going to prove them parallel, that means that you're going to prove that those angles are congruent, and if they're congruent, it'll prove that L is parallel to M. So remember, these are corresponding angles, which means they should be congruent. So what we're going to do is we're going to say that 3x plus 6 is equal to 4x minus 6. It has to be if they're congruent. We're going to subtract 3x from both sides, doing a little algebra. So I'm going to have 6 equals x minus 6. Add 6 to both sides. I got 12 equals x. And so now if I say 3 times 12 plus 6 should equal 4 times 12 minus 6. Gives me 36 plus 6, gives me 48 minus 6, and that's 42, and that's 42. So M is parallel to L. And that's all you got to do for these kind of problems. If you look at this one, oh, and I guess we might want to say here that they are corresponding angles. That's why they're congruent. Now here with number 6, they're alternate exterior angles. So we're going to have an alternate exterior angles are congruent to each other. So all we have to do is set the expressions up equal to each other. This time I'm going to subtract 5x from both sides. And then I'm going to add 24 to both sides. And I have to put me a little 24 there so I can do my addition. It's 42. Divide both sides by 2. I get x equals 2. Now I'm going to plug that in. Alright, so I have 14 minus 24 equals 10 plus 18. 14 minus 24 is going to give me I'm sorry, I was just sitting there thinking 14 minus 24, that gives me a negative 10. That gives me a 28, and I'm wondering if I did all my math correctly. Okay, I got 5x there. Because usually when you set these up equal to each other and you solve them, they automatically come out. That's 12. I carried my 1. That gave me 4. Okay, so I'm silly. Look at that. 2x divided by, or 42 divided by 2x is not 2. It's 21. No wonder my problem wasn't working out. So you always need to, if things aren't working the way they should, you got to go back and check your math. So 7 times 21 is going to be a big number. Got to figure that one out. 7 times 21 is going to give me 147. 5 times 21 is going to give me 105. 147 minus 24 gives me 123. And then 105 plus 18 also gives me 123. So L is parallel to M. And you would work this last problem the same way. Those are alternate interior angles, and you might want to try that and give it some practice. See if it works for you. You can also watch the recording because I use the same example in the recording I did for proving lines parallel. Okay. Then we had the triangle sum theorem, which tells us that all the interior angles of a triangle add up to 180. They're giving us this quadrilateral, RSTU, and telling us that the measure of RVS right here, is 72 degrees, and that SRV, SRV is right here, and it's congruent to RSV. Those two guys are congruent. And then they want us to find all these angle measures. Well, I'm just going to start from what I know right here. All these angles measure up to 180. So you could say that the measure of RVS plus the measure of SRV plus the measure of RSV, I just ran out of room, equal 180. So I know this guy right here is 72, And I don't know these two guys, but I know that equals 180. And since they're congruent, let's call them x. Because since they're congruent, I can call them both x. So I'm going to have 72 plus 2x equals 180. I subtract 72 from 180. Gives me 108. I divide both sides by 2. I get x equals 54. So both of these angles up there are 54 degrees. Let me get my eraser. Let me erase all that. Because that information right there is going to help me find the measure of my other angles. Now then, it says it's a quadrilateral is a rectangle. So that tells me this angle's 90 degrees, this angle's 90, this angle's 90, this angle's 90. So I can say 90 degrees minus 54 is going to give me, look at me doing some math here without a calculator. Those are going to be 36 degrees. There we go. So now then, I know that this angle down here is 90 degrees. I know this angle's 36, so all of that's going to help me find the measure of that angle. Because I can take 180 minus 36 minus 90 will give me the measure of that angle. So I'm going to say 180 in my calculator minus 36 minus 90 gives me 54. Now, another trick you could have used is this is a transversal to parallel lines, okay? And then those 54 and this 54 are alternate interior angles. And by the way, this angle over here is also 54 degrees. So let's see, it said SRV, so that was 54. This one was 54. It said VRU, 36. VST, 36. RUV, 90. And we knew that because it was a rectangle. Same for STV. RVU is 54. We said we could do that with either alternate exterior angles, or we could use the triangle sum theorem to figure that one out. Now then, this one says find the measure of each angle, and they want to know the measure of 1, 2, 3, 4, 5, and 6. Okay, to find the measure of angle 1, I got to use the triangle sum theorem to figure out the measure of this angle. So you're just going to take 180 minus 36 minus 68. Keep picking up my phone to use it as a calculator. 180 minus 36 minus 68 gives me 76. So now I can say 180 minus 76 because these guys right here are a linear pair. And that gives me 104. Alright, for angles 2 and 3, I got to do a little bit more work over here. This angle right here and this angle right here are a linear pair. So 180 minus 36 is going to give me 144. This angle right here is also 144. Oh, and I'm so silly. These two guys right here are congruent, so that's 36 degrees. Now then, if you come over here, you almost think you got it whooped, but you got to draw you a little extra line right here. You can see that angle 3 and this angle right here are congruent because they're vertical angles. So since I know 65 and 36, I can subtract those from 180 to get angle 2. Let me write angle 1 up here. 104 degrees. Angle 3, I'm going to put right here 65 degrees. Angle 2, 180 minus 36 minus 65 gives me 79 degrees for angle 2. Angle 4, oh look, all three of these angles right here form a linear pair, so I can say 180 minus 65 minus 70 gives me 45 degrees for angle 4. And then if you look right here, these guys are a linear pair. So 180 minus 118 is 62. And then I can find angle 5 through the triangle sum theorem. 180 minus 62 minus 45 gives me 73. Okay, now let me see how I find angle 6. Angle 6. Oh, okay. I'm going to use 65 and 82 to figure out the measure of this angle right here, because that angle and angle 6 are a linear pair. So 180 minus 65 minus 82 gives me 33 degrees, and I subtract that from 180 and I get 147. So, and like I've said before, these kind of problems are my favorite because they're just a big puzzle, putting everybody together. Okay, angles and polygons. It says if a convex polygon has n sides and S is the sum of the measures of its interior angles, then the sum of its interior angles is going to be 180 multiplied by the difference of n and 2. So, and over here they give you an example with the pentagon. You plug the 5 in for the number of sides and do the math. So let's look at this little problem. It says the Paddington family is assembling a hexagonal sandbox. What is the sum of the measures of the interior angles of the hexagon? So I'm wondering, oh, that's a shovel and a pail. I couldn't figure out what that was over there. So if it's a hexagon, you got to remember how many sides it has. 1, 2, 3, 4, 5, 6. But hopefully you remember that just because of the word hexagon. So we're going to plug in that, which equals 180 multiplied by 4. I'm going to put that handy dandy calculator. That gives me 720. That's the sum of the interior angles. Now it says find the sum of the measures for the interior angles of a nonagon. Well, you're going to do it the same way. You're going to plug 9 in for n minus 2. That's going to give you 180 times 7. So 180 times 7 gives you the sum of the interior angles is 1,260 degrees. You've got to remember that whenever you're doing the sum of the interior angles, that you're going to have 108, but you're going to have to multiply that by n, because you know that's the sum of, that's the measure of one interior angle, and we don't know how many sides it has. So you have to include that n with your 108. And then you go ahead and you do your math, distribute your 180, and then I'm going to get my ends on the same side. So I'm going to have that's a negative 72n equals a negative 360. I divide both sides by the negative 72. And I get n equals, let me see what 360 divided by 72 is. And notice the two negatives are going to make it positive. So that's the number of sides, which is a pentagon. You do the same thing down here. It tells you the measure of one interior angle is 135. Well, since we're looking for the number of sides, we're going to have 135n equals 180 n minus 2. Go ahead and distribute that 180. And you're going to get used to this. You're always going to get the same thing. 180 n minus 36. I'm going to subtract 180 from both sides. Oh, I did the wrong number. Minus 180. So I get a negative 45n equals a negative 360. So I divide 360 by 45. And remember, two negatives make it a positive. So n equals 8, and that will be an octagon. Okay, interior angles of non-regular polygons. Well, this is a quadrilateral, so you know all of the angles are going to add up to 360. And you know that your n is 4 because it is a quadrilateral. And the sum of the measures of the interior angles, and look, they went ahead and figured that up for us, but we knew it was a quadrilateral and it was going to be 360. So if I want to find out what x is, I can say x plus 2x plus 2x is going to equal 360. You're going to add all those x's together. That's 1, 2, 3, 4, 5, 6. Do you some mental math here? 36 divided by 6 gives you 6. So x is going to equal 60. So that's 60, that's 60, that's going to be 120, and that's going to be 120. So we found the measure of each interior angle. This check your progress down here is going to work the same way, but if you'll notice, this is a hexagon. Okay, so you're going to have 180, and then 6 minus 2 will give me 4. So those interior angles are going to add up to 720. So there's 4 of these. There's 1, 2, 3, 4. So I'm going to say 4 multiplied by 9x and 30 plus, and then there's 2x's. Plus 2x is going to equal 720. I just did that so I wouldn't have to write all that stuff over and over and over again. Up here I could have went 2x plus 2 like that, or I could have just added them all up in my head and did 6x to begin with. But you've got to distribute the 4. And then you've got to multiply the 2 and 2x. And then go ahead and combine your like terms. So you're going to have 40x plus 120 equals 720. You're going to subtract that 120 from both sides. So you're going to end up with 600. And divide 600 by 40. You're going to get 15. So x equals 15, so this angle right here is 30 degrees. That means this guy over here is 30 degrees. If I take 9 times 15 plus 30, 9 times 15 plus 30, that gives me 165. So each one of these guys right here are going to be 165 degrees. The next you have your exterior angles theorem, and what you have to remember is that your exterior angles are always going to add up to 360. So it says find the measure of the exterior angle and the interior angle of the convex regular octagon ABCDEFGH. So to find the interior angles, I'm going to take oh no, not an S. I'm going to do a little I. I'll get it right in a minute. 180. It's an octagon, so it has 8 sides. And then I'm going to divide that by 8, or angles. It has 8 angles. So 180 times 6, because that's going to be 6. 180 times 6 is going to be 1080 divided by 8 gives me 135. So each one of these interior angles is 135 degrees. I'm not going to write all of them, but just to give you an idea. Well, look here. These angles right here are a supplementary pair, aren't they? So I can say 180 minus 135, 180 minus 135 is going to give me 45. Or there's another way you could do it. You could use the formula that we learned. 360 divided by n is going to equal the measure of each external angle. So I've got 360 divided by 8. It's going to give me 45. So you could figure that out either way. Now we're going to look at the mid-segments of trapezoids. And right here, so I'm going to have EF, or you could say the mid-segment.
She has two?
B1 plus B2 divided by 2. Okay? So in the diagram, QRST represents an outdoor eating area in the shape of an isosceles trapezoid, and the median XY represents a sidewalk through the area. And we are supposed to find TS if QR equals 22 and XY equals 15. So QR is going to be 22, XY is 15. So we need to find TS, which we're going to call X. So remember, my mid-segment is XY, and it's going to equal QR plus TS divided by 2. So I'm going to have XY is 15 equals QR, and I'm going to call TS X divided by 2. Well, remember, you can always make that a fraction, and then we just do some cross multiplication. So we're going to have 30 equals 22 plus X. I'm going to subtract 22 from both sides. I'm going to get 8 equals X. So TS is 8. Let's work an algebraic problem like that. This one says JKLM is an isosceles trapezoid where JK is parallel with LM, and they tell you that so you'll know how to draw it. Okay? And then the median is RP. It says find RP if JK is 2 multiplied by the sum of X and 3. RP is 5 plus X, and then ML is 1/2 X minus 1. So, and we're supposed to find RP, but we're going to have to work all this out with the mid-segment theorem to figure this out. So we know that RP equals JK plus LM, just divided by 2. And so we're going to plug in what we know. RP is 5 plus X. JK is so you've got to go ahead and simplify everything before you start doing your cross multiplication. So first I got to do some distribution. So I'm going to have 2x plus 6 plus 1/2 x minus 1 all over 2. And then I got to combine like terms. So I'm going to have 2.5x plus 5. And I combine those two and these two. That's all divided by 2. And now I can go through and do my cross multiplication. So I've got 2 multiplied by 5 and x equals, and then anything times 1 is just 1. So I got 10 plus 2x equals 2.5x plus 5. Subtract 2 from both sides. I got 1/2 x plus 5. I'm going to subtract 5 from both sides. And now, you're always, oh no, what are we going to do? I got a half. Just multiply both sides by the reciprocal. That's all you got to do. So I've got 10 equals x. So if I'm going to find RP, I just plug in 10 and RP equals 15. And if you want to just check yourself, plug in a 10 there. 2 times 13 is going to give me 26. Plug in a 10 there, that's going to give me a 5 minus 1 equals 4. I add those two together, 26 and 4, divide by, that's going to equal 30. Divide by 2, I get 15. So I did a little check there. Okay, the midsegment theorem also works for triangles. And remember, with triangles, your midsegment is going to be half the length of the base. So let's just work this one. I think I may have worked this one in a recording. I'm not positive. But what we're going to do, it says find x and then the measure of the segments. So what I'm going to do is say that DE is going to equal half of AB. DE is x plus 6. AB is 3x. So I got x plus 6 equals 3x over 2. Now remember, put in 1 there and do some cross multiplying. So I'm going to have 2x plus 12 equals 3x. Move that 2x over and you find out that x equals 12. You plug that in here. 3 times 12 is giving me 36. Plug that in here and it works out because half of 36 is going to give me 18. Oops, wouldn't finish writing that. Oh, I see what I did now. I'll put equals 18 like that. Okay, since this recording's getting a little long, I probably won't do every one of these, but I'm going to do this first one and then you can use the next two for practice. I'll give you what the answers are and then you can work out the slope formula to figure out what's what. It says to determine whether PQ is parallel to UV. So you're going to have to use the slope formula for both lines. And remember, if the slopes are equal, let me see, they have the same slope, they're parallel. If the product of the slopes is -1, they're perpendicular. If it doesn't meet either one of these, it's going to be neither. So these are same. Perpendicular is going to have the product of -1, and then neither is just neither. So on this first one, remember I always go through and I label. I'm going to go ahead and label these guys too. Okay, so let me bring this down a little bit. So for P, this is for P, we're going to have 1 minus a -2, 9 minus a -3. Remember those negatives, 2 negatives make it positive. So 3 over 12, I can reduce that to 1 over 4. And now I'm going to do, oh, that was for PQ. Now I'm going to do UV. That's going to be -2 minus 6, 5 minus 3. So that's going to give me a -8 over 2, which gives me a -4. So if you look, you've got 1/4 multiplied by -4 over 1. That comes out to be 4 over 4 negative. So your product is a -1, so those lines are perpendicular. I'm going to tell you right now that I'm pretty sure these guys are parallel and these are neither. What you need to do is work out the formula slope to see if those two answers are correct. Now in this one, it's just the midpoint formula, and you're going to use the midpoint formula to see if what the midpoint is. So my midpoint for this one, I'm going to plug in x1 is 8 plus 12 divided by 2. I got 4 plus 2 divided by 2. So that's going to be 20 divided by 2, 6 divided by 2, 20 divided by 2 is 10, and all I'm doing is simplifying them now. So right there is my midpoint. Same thing with this guy down here. I'm going to have -11 plus a -9 over 2. Then I'm going to have -4 plus a -2 divided by 2. That's going to be a -20 over 2. That's a -6 over 2. Look, that's almost the same. -10, -3. And then this is going to be our last example, and this is just finding the midpoint if you know one endpoint. They tell you find the coordinates of A if B is 0 and 5.5 is the midpoint of AC. So I was just doing that so I could figure out who the midpoint was. And it says the coordinates of C. Oh, I'm going to do this the other direction. I like to work down. So I'm going to call this C. I'm going to call this A because I'm finding A. They tell me B is 0 and 5.5. They tell me C is -3 and 6. So what you do is you think, how far is it from -3 to 0 on the number line, and are you going to be adding or subtracting? Well, in this, you're going to be adding. And then from 6 to 5.5, I'm going to be subtracting 0.5. So you're going to do the same down here. You're going to add the 3 to the 0. You're going to subtract the 0.5 from the 5.5. So your coordinate for A is going to be 3 and 5. You're going to do the same for this problem down here. I got to figure out who's in the middle. Find the coordinates of if S is in the middle, and they give me T, and I got to find R. They tell me that T is -4 and 3, and that S is -1 and 5. Well, from 4 to 1, I would be adding 3, and from 3 to 5, I would be adding 2. So I'm going to do the same down here. -1 plus 3 is going to give me a +2. 5 plus 2 will give me 7. There you are. And I'm sorry this video ran so long. I just wanted to give you plenty of examples. And good luck on the test, and thanks for listening.